In an amazing new development, NASA's James Webb Space Telescope has made a revelation that has stargazers around the world in wonder. Half a month prior, the telescope found the earliest known system in the universe. However, presently, it has recognized something significantly more enormous. A very gigantic dark hole moving away from its system at a staggering rate of 4 million miles per hour. This latest discovery has vital ramifications and has created a lot of theory among scientists and space enthusiasts about how it affects how we might interpret the universe. The James Webb Space Telescope was sent off determined to investigate the first systems in the universe and has captured dazzling pictures of the passing of stars and galaxies from a few 100 million years after the Big Bang. We welcome you to join us to explore the latest discoveries from this telescope. Make sure to like and subscribe for more content like this one. The most recent discovery is challenging the scientific community's ongoing understanding of dark holes. Dark holes are generally considered tremendous entities that draw everything, including light, towards them. However, the recently observed dark hole seems to be making the opposite difference. Rather than absorbing light, it is creating new young stars along a long trail. This new path of baby stars has been seen right after the dark hole, which stretches an incredible 200,000 light-years away. Scientists are amazed by the unusual behavior of this dark hole compared to others, but a team led by Johns Hopkins University astronomy professor Peter B. recently reported their findings in the astrophysical journal Letters. NASA's Hubble Space Telescope also confirmed these observations, suggesting that the dark hole stirs new stars when it comes into contact with gas and cools it. We are seeing the wake behind the dark hole. But that's not all. NASA has made an exciting announcement about the cosmic merger ARP-220, which was captured by the James Webb Space Telescope. This grand cosmic merger should be visible sparkling among other galaxies in the night sky. When two swirling galaxies merge, the peculiarity known as ARP-220 shines brightest in the infrared, making it ideal for observation by the James Webb Space Telescope. It is named an ultraluminous infrared galaxy with a glow of 1 trillion suns, compared to our own galaxy, the Milky Way, which has a much lower radiance of around 10 billion suns. ARP-220 is located in the constellation of Serpens around 250 million light-years away. It is considered the brightest of the 3 nearest cosmic collisions to Earth and is listed as object number 220 in the Atlas of Peculiar Galaxies. Around 700 years ago, 2 swirling galaxies collided in a massive burst of star formation. This created a dense region around 5,000 light-years across that contains around 200 large star clusters. Surprisingly, this small area contains as much gas as the entire Milky Way. Previous observations with radio telescopes found around 100 supernova remnants in under 500 light-years across. Then, the Hubble Space Telescope revealed that the parent galaxies are located 1,200 light-years apart, and that each core contains a rotating ring of star formation that produces astonishing infrared light. The latest views from the James Webb Space Telescope show a spectacular cosmic merger of the 2 galaxies. This image also shows faint tidal tails extending from the edges of the merger, indicating the gravitational pull between the 2 galaxies. Finally, the red, cyan, and orange streams and fibers represent dispersed organic materials in ARP-220. Another stunning discovery puzzled scientists when researchers found early-stage galaxies at the edge of the universe. They had 1 or 2 glaring misgivings about their credibility. Some thought they might be nearby galaxies in camouflage, so they shared the data with other scientists worldwide, hoping for validation. Incredibly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this revolutionary telescope, we can now observe the oldest galaxies ever seen. Stargazers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, giving us a glimpse into the distant past of the universe. These galaxies were found when the universe was young, which sheds light on how rapidly the first generations of galaxies arose. The spectral data confirm that these galaxies are at the edge of our view, some much farther away than Hubble could see. The discovery is significant because it validates one of the most important missions of the James Webb Space Telescope, to study the early universe through light that has been traveling for over 13.5 billion years. The ability to measure extreme redshifts sets James Webb apart, allowing astronomers to peer into the infrared range and observe the first galaxies in the universe. The excitement in the air is palpable as this discovery marks a major milestone in the exploration of the universe and in understanding its evolution. The discovery has had a significant impact on how we understand the universe and has prompted NASA to develop even more powerful telescopes than the James Webb Space Telescope to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb spectrometer and near-infrared camera have revealed that 4 of the 6 early-stage galaxies have extreme redshifts, suggesting that Webb is observing them as if they existed 300 to 500 million years after the Big Bang. Without heavy elements such as carbon, this is as astonishing since the universe is estimated to be 13.8 billion years old. The existence of these galaxies suggests that we need to revise our understanding of the early universe. This has raised concerns in the scientific community as these new discoveries challenge the current cosmological expansion model and the theory of how things came to be, which has several loopholes, such as violating thermodynamics and lacking a clear explanation of what caused the Big Bang. Moreover, the James Webb Space Telescope is finding galaxies nearly as old as the Big Bang itself, which questions everything we thought we knew about the origin of the universe. Theoretical physicist Neil figured out that it takes billions of years to create a galaxy like the Milky Way, so it is surprising to see such massive young early-stage galaxies. This discovery may require us to rethink and adjust the textbooks on the beginning of the universe. Findings from the James Webb Space Telescope challenge what we thought we knew about the Big Bang, leaving scientists at an intersection. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another fascinating piece of the puzzle. Astronomers have examined the data and concluded that this young cluster is expected to grow in size and become something akin to the giant ellipticals. Where this is happening is unique and exceptional, as it is in a region of accelerating cosmic development. Thanks to the James Webb Space Telescope, experts can now measure the speeds of these 7 galaxies, which gives them the confidence to confirm that they are bound together in a protocluster. To put this in perspective, NASA scientists liken these distant galaxies to small droplets of water in different streams that will eventually merge to form a large solid stream. Clearly, what we previously believed about the Big Bang isn't unfolding as expected. However, more data from the Webb telescope may uncover evidence that could confirm or refute the theory. Who knows, perhaps the Big Bang occurred, but what caused it is a different story. Regardless, we will have to wait for further discoveries, but the answer may be closer than we think. The James Webb Space Telescope, JWST, a wonder of modern astronomy, represents a culmination of many years of scientific and technological advancement aimed at looking further into the universe than ever before. Sent off as a successor to the Hubble Space Telescope, JWST carries with it the promise of unraveling some of the universe's deepest secrets, from the formation of the first galaxies to the nature of dark matter and dark energy. One of JWST's primary objectives is to explore the origins of galaxies, stars, and planetary systems. By observing in the infrared range, JWST can penetrate cosmic dust clouds that obscure visible light, providing unprecedented clarity in observing distant celestial objects. This capability is crucial for studying the early universe, where the most distant and ancient galaxies reside, their light having traveled billions of years to reach us. In its mission to unveil the cosmic dawn, JWST has proactively made significant discoveries. Among them is the detection of early-stage galaxies dating back to the universe's infancy. These ancient galaxies offer a window into when the first stars ignited and the universe transitioned from a dark region to a tapestry of glowing galaxies. The ability of JWST to capture detailed images and spectra of these early galaxies is a testament to its advanced technology.